Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Thermal decarboxylation of malonic acid derivatives, beta-keto acids or malonic acid type diacids, proceeds via a cyclic six-membered transition state. When a compound bearing two carboxylic acid groups, a malonic acid type or 1,1-dicarboxylic acid arrangement, is heated, one CO2 is lost. The key question is which CO2 is lost and what stereochemistry results. Moving on to the next step. Identify the starting material. The starting material is a bicyclic compound, norbornene type or bicyclo framework, bearing two CO groups on the same carbon, geminal dicarboxylic acid, i.e., malonic acid derivative at a ring carbon. One CO2H appears to be on a bridgehead adjacent carbon and another on the same carbon, gem diacid, making this a substituted malonic acid. Moving on to the next step. Thermal decarboxylation mechanism. A gem dicarboxylic acid, malonic acid type, loses CO2 upon heating via a cyclic transition state to give a monocarboxylic acid. The product retains one CO group. And for the final step. Stereochemical outcome. In the bicyclic system, the carbon bearing both CO groups loses one CO2. The remaining CO can be in two orientations. The proton delivered in the cyclic TS can come from either CO group acting as donor, giving two possible stereochemical products at that carbon, one with CO in the configuration shown in A and one shown in B. Since decarboxylation via the cyclic six-membered TS can proceed through either CO group donating the proton, both epimers at the resulting carboxylic acid carbon can form. Why both A and B are correct? The thermal decarboxylation of a malonic acid derivative embedded in a rigid bicyclic system can produce both possible stereoisomers of the monocarboxylic acid product, because the cyclic transition state geometry allows loss of CO2 with the proton delivered to either phase. Both option A and option B represent the two stereoisomeric monocarboxylic acid products differing in the configuration of the CO-bearing carbon. Why D fails? Both A and B are legitimate products, so none of these is incorrect. Therefore, the correct answer is C. Therefore, the correct answer is option C.